So, welcome to your summer semester. Yay. Um, this is week one. You're just getting used to the school. Uh, Today is basically just an introduction to the course and the content and some of the basic concepts. Um, there is some lecture material today, but not too bad. Um, this one I usually give my warning about this course is the first 4 or 5 weeks tend to be rather intense, and then it slows down after the break. Just That's just how the material is. So the first little bit, we're going to be using the whole time. So I usually give you guys a bit about who I am, so you know where I come from. And so I graduated from Canadore College in 1996. That's probably before a portion of you guys were born. Um, so yeah, no, that doesn't make me feel old at all. Uh, because that means I started 3 years before that, my college, right? Um, I don't have a degree. I just have a college diploma, a 3-year diploma, um, with a focus in business systems, because that's how it was back then. I've been a developer more or less ever since. Literally unemployed for a grand total of maybe 3 weeks in those years. 3 weeks are not by choice. Any time off I did. So I work full time and I teach part time. I usually give you guys that warning because that means that I don't have regular office hours. By the same token, I tend to be very responsive with my emails. So if you email me with a problem, I'm usually fairly responsive. Um, Currently, I'm working as a team lead with, actually, I need to change that because there's more to it than that now, but lead at Health Canada. I literally work across the street from here. My office is just on the corner of Woodruff and Baseline. Yeah, literally just over there. 5 minute walk, 10 minute walk. So I spent 26 years before that as a developer in the private industry, as a full stack web developer. And I did a side of AWS administration in my last 6 years before I joined the public service. I literally did for a living what you guys are going to school to learn. I did the whole thing from setting up servers to front end development to database work. Um, I am a database specialist, just so you know. Uh, Means I can do the rest, but I'm a database specialist. What kind of prof am I? I tend to have a fairly loose and easygoing teaching styles. I don't have class notes because A, I've been doing this stuff for a living for so long that I don't need to think about the material. And two, I've taught, various flavors of these courses for uh, 19 years almost. So I just deliver the material. The I tend to understand that life happens within reason. This is gonna be a little weird because it's the first time I haven't had the labs to go with this, but um, to my understanding, your lab prof is fairly reasonable also. I've worked also with him for a long, long time, so we've known each other for a long time. Um, but that being said, I don't tend to have a lot of patience for repeated issues. Oh, my laptop, my dog peed on my laptop. Third week in a row. That doesn't fly. Either you need to train your dog better, or you need to stop leaving your laptop on the floor. Um, or you just have an insane amount of money, which I've never heard of a student having an insane amount of money available to them to, replace stuff. Just saying, like, yes, I understand life happens. I'm fairly reasonable. By the same token, you know, just be reasonable. Um, I've also been told I'm fairly not politically correct, in the sense that I will use bad language in class. 26 years in the private industry has not beaten bad language out of my system. If nothing, it's made it worse. Um, but I am fairly careful about some topics. And I've been known to, tease my students a bit. Um, I tend to try to keep things a little informal because, over the years I've learned an awful lot from my students as much as I'm trying to teach them. Therefore, I don't believe I'm any more superior than you guys. You all have skills that I probably don't have of some sort somewhere. So I tend to not try to be that kind of person. Okay, so some best practices for CST8260. Attend lectures and labs. I mean, goes without saying. Um, Now, you'll notice that I'm wearing a microphone, and some of you may notice I've got a camera pointed at me. I record my lectures. It's a value-added service. In other words, I do my best with it. It comes when it comes. Usually, lecture recordings are loaded up within 24 hours. But the issue is if you don't come to class and then you have questions, your questions are being delayed because, it's not in the moment. So coming to the lectures is important. And I know Saif, your lab prof, is very strong on attendance to the labs. So attend. Um, so this, as I warned you guys earlier, this course moves rather quickly. Only 1 hour a week of lecture, and it's a fair chunk. It's possible if you miss a lecture that start falling behind. Thus, another reason why I record the lectures. So, if you miss the Thursday lecture by Friday by noon, you should have the lecture will probably be loaded. Historically, it's usually in the same day, but I've got 2 lectures on the same day this year, so this semester, so it's going to be a little harder for me to rip the video and upload to YouTube. But yeah, if you are sick or something terrible happens, try to contact us as early as possible, either myself or your lab prof, because it's really hard to be sympathetic when somebody reaches to you after they haven't submitted 3 labs and say, "Oh, I was sick." Like, bro, it's been 3 weeks. In that 3 weeks, you couldn't have just a line or email saying, "Hey, I'm really sick." Yes, if you're in the hospital, obviously that's different. But if you're sitting at home sick because you ate some bad chicken, ate some tofu that had a little bit of something growing on it, you know, I'm sure while you're sitting on the toilet, you can send me a one-liner. So yes, it's a two-way street. Um, I almost never miss a class for lecture. Just so you know, like, of course I'm saying that, and this is the time it's going to happen. But in my 19 years, I've missed 2 lectures. So I make the effort to be here. Please do the same. Um, all the course materials on Brightspace. Everything is based on the slides and the hybrids. Um, that is a PDF version of the textbook that used to be 1 years ago. It's now gone. There's no textbook. I keep forgetting to edit the slide to take that line out. So any extra content will be there as needed. Slides are all posted ahead of time. I hide nothing in my course shell. Therefore, read ahead before you come to class because other than today, I'm not going to use the slides. Because we only have an hour of lecture, I have 2 choices. I can either read the slides to you or I can just do it all as a live demo. I'd rather do it as a demo where I'm demonstrating what I'm talking about as opposed to reading points on a slide deck. You guys are able to read. Obviously, you've arrived to college. You must be able to read enough to read a slide deck. Therefore, you don't need me to read it to you. Like I said, 1 hour is not time for a 30-slide deck and the demos that need to go with it. So I lecture the content as demonstrations. So it's very practical. So even then, you should still read through the slide deck before, because whatever's in that slide deck is what I'm going to be talking about and demonstrating. Check Brightspace on the regular. I will, guys, one announcement a week. In that announcement, it'll say, these are the labs, this one it's due, here's the link to the lecture recording, here's the link to the hybrid you need to do this week. One announcement a week that tells you everything that's supposed to be happening in this class. Again, some profs like using the CSI, or what they call it now, then you guys have to go read this weird Word document to try to figure out what you're supposed to be doing. Nah, dude, I put it in an announcement. It's much more obvious. And since it's tied to your email address, it goes in your inbox at the same time. All right, do the labs. That's a good starting point for your success, because the course has 2 tests, a handful of hybrids, and labs. Also, 2 practical assessments that you're going to be doing in lab. And if you haven't done the labs before trying to do that practical assessment, not going to be a good time. Just saying. Currently, unless Saif has changed the rules, but he hasn't gotten back to me yet, labs have a 20% deduction right off the top. So if you are late, and that's up to Saif to apply it what he calls late, like some profs, 5 minutes late, they don't care, but some do. So whatever he tells you, that's how it's going to go. There's a 20% deduction. At the end of a week, you get a 0. In the real world, if you're more than a little bit late, you tend to have to explain why you're late. I don't care why you're late. I'm just going to punish you for it. Or in this case, your lab prof will punish you for it. So this is why, remember I said communicate early? That's why. Don't hesitate to ask questions. Whenever you have a chance, work with your peers. Often your peers are as good a source of learning as the prof is. Then practice. All right, so the breakdown of your grades are labs, 35% of your grade. The practical assessments, 25% of your grade. So basically put 60% of your grade comes from your labs and the practical assessment. You don't do them, you just failed. So do them. The hybrids are worth 10%, and the 2 tests, the midterm and the final, is worth 30%. So that's how the grades are broken down in this. Brightspace should show you the percentages when you look at the grade book, how it's calculated. So this is a 224 class, what they call a 224. I don't even know if they use these terminologies with you guys anymore when they're explaining course content, but it means that you have 2 hours of theory, another 1 hour in class, 1 hour hybrid. The hybrids in this class is, there's something I want you to read, and then you go do a quiz. You get 2 tries at the quiz. They're in the calendar for the course. There's no excuse to not do these hybrids. You have a 2-hour lab, and then they assume you're going to do 4 hours of study time. Usually it's about 2 to 1 for the, but that study time depends on you. In other words, some people will pick the stuff up like this. Some people are going to be rolling on the floor crying, depending on how your brains are wired. But that's how it is, right? So we say 4 hours of study. One person might only be an hour. One person might be 5. Do a bit of averaging. You end up with 3 to 4 hours. I can't tell you how long you should study because I'm not you. Okay, a few college services to help you succeed. Many profs don't give you these things. And sometimes the colleges don't even tell you. But so Cal is an amazing resource here at the college, a Center for Accessible Learning. Whether you have a physical challenge, a neurodivergent challenge, you got really bad ADHD, whatever it is, Cal can get you assessed and get you some guide rails put in place for you. My daughter went through it for the 2 times she came through Algonquin. They were fantastic for her. So, and they didn't know I was a prof, you know, we never communicated that we were related. So they treated her just like anybody else. And she had tons of resources for, you know, if you got really bad ADHD and you need somewhere quiet to write your test, or you need noise canceling headphones, they'll take care of that for you. They're really good. Tutoring. It's $8 an hour. So if you really get stuck and you know you just want to get somebody to help you, $8 an hour, and they actually do have financial assistance where they'll cover a certain part of it, so it's even less. Um, Algonquin's mental health support services. Um, Maybe you're just having a bad spot and you need to talk to someone. They actually have counselors. It's completely professional, and you know, um, and there's a bunch of other support services if you go to that last link. Um, okay, good. I'm right on schedule. This. Oh, and also the food options in the summer aren't as good as they are in the winter. Just the fall and winter terms. The food options in the summer on the campus not so great. I'm pretty sure the cafeteria in B building's usually closed. I'm not sure if the cafeteria in CA is open during the summer. I think it is. I remember they got it closed this year, or we don't know. So that cafeteria, by the way, the cafeteria in CA, pretty legit. Significantly better than what's in B building, so no loss. B building, oof. Cafeteria as usual. The Wolf's Den are also decent places. They usually have the observatory closed during the summer. And T building has Bits and Bytes, which sometimes is open in the summer, sometimes it's not. I think it depends just how many students they have. So low enrollment this summer, so I wouldn't bet on that one being open. Okay, now to get into the meat of today. Now that we've done before I start the rest of this lecture, does anybody have any questions for me? Oh yeah, so let me go and let me just pull open Brightspace and show you guys this one. Uh, Content. Now this is the prof view, not the student view. So I see more than you guys see. Um, you will have in here there are 8 hybrids, and each hybrid is go read this, do the test. No, that's on your time. It's part of your homework. When they talk about the 2 hours of learning, 1 hour in class, 1 hour on your own. This is what you do on your own. We don't do that in class. No, no, don't have time for that. Just don't have time for that. What else is in here? You got your course information. Shows who's doing where, what room you're in. When I do the recordings, I'll be posting links in the recording section to where I post them. The slide decks are all in here and all the lectures. Um, the labs are all here. Oh, he hid all the other labs, but anyways, lab 1's visible. Um, and then later on, you'll have the practical assessments will show up when it's time. Very simple course shell. Everything's there. Everything's in Brightspace. There's no documents to download, no PDFs to download, none of that. It's all in Brightspace. Well, obviously, except for the databases you have to download, but Okay. Any other questions before I continue? Quizzes? If you click on hybrids, um, yeah, and then you got a link right below it that says like hybrid 1. And then that'll bring you into the quiz. Oh, hang on. I know what's wrong. Yeah, hold on. Now it's going to show. Here, and this one. know why everything got disappeared on you, but they were there. They were visible because I did log in as a student to look, and they were there before. So I'm not sure why things were disappeared, but that's okay. Thank you for bringing that up because I would have gone through the next week and why is nobody doing the hybrids? And that would have been why. If you notice anything with the course shell, let me know. I will fix it as fast as I can. Okay, now for today's content. I use a clicker, not the mouse, but I forgot to change the battery in my clicker. So that's why I'm doing the lean. Um, okay, so you're going to learn a lot about what I'm going to talk about today is really basic. You're actually going to learn a lot more about this in level 2. How do I know? Because I often teach that course too. Uh, Actually, literally after this class today, I'm running downstairs to go teach the level 2 that follows this. So I completely know how the two courses go together. So this is a course about database. Specifically, you're going to be focusing on SQL, but you need to understand a little bit about concepts of databases. Um, so a database in its barest form is a collection of logically organized related data. In other words, it's got tables and supporting objects that allow the data to be contained. Data stored in tables. How many of you have used Excel or a spreadsheet? Okay. For the the ones that don't use Excel, they've used Google Sheets or, God forbid, Mac numbers. Um, no, that's not what really is inside the database, but that's basically what it. If you want to think about it, that's roughly how the human would understand what's inside a database, at least a fictional database, where we have columns and rows of collections of columns. Um, Databases are based on the mathematical set theory. Um, so some of you may remember set theory when you went to school. Not if you were a Canadian student, because apparently they don't teach that shit anymore. But if you're an international student, you probably did learn it. Matrices and unions and that kind of stuff. Um, Usually when I say, remember learning about set theory, all the international students go, yes. The Canadian students look at me, they go like, what are you talking about? Go Canada. Um, there's a lot of theory behind database. The good news is for this course, there's not a lot of theory because it's all hands-on. There is, when it was originally created, that relational databases were created, um, the primary data scientist that created, a lot of the concepts is a fellow called C.J. Date. He actually, they basically created an entire branch of mathematics just for database. I had to study it. Thankfully, you guys don't. I remember taking it when I went through school. It was about that much of a textbook, and I wanted the best sleep aid you ever had. Um, for you guys, you basically need to just understand Boolean logic, which is good. Okay, so databases hold structured data. They contain collections of columns, also known as fields, and rows, also known as records. If you hear me say the word field, it means a column. If you hear me say column, it means field. They're interchangeable. A row and a record is also interchangeable. Um, a database usually contains more than one table or more than one entity. Um, in the tool you're using for this course, it's called DataGrip. With DataGrip, those are screenshots that come from DataGrip in DataGrip dark mode, so it actually shows up on a white slide properly. Um, it looks, if you look at the picture on the left, it literally looks like a spreadsheet. That's when you're interacting with the database. An entity, also known as a table, is a representation of real world data. It has attributes which define the entity. The attributes are basically columns or fields. And level 2, you'll learn about entities and attributes ad nauseum. For now, you just need to worry about the fact that a table is made up out of a set of fields. In this example, They got an entity called city, and the city has a name. The city belongs to a country by the country code. It has a district and a population and a primary key. Um, Relational databases have relationships. Uh, Basically put, it's a connection between two tables that the database enforces rules on. For the intents and purposes of the level 1 course, you basically have to understand that tables can be related to each other. The way it works is you'll have a table with a primary key, which I'll talk about in a bit, and then you have a foreign key. The primary key is a unique identifier for a table. I have the each example for you guys to remember. What is your primary key here at Algonquin College? Your student number. That is your unique identifier here at the school. No two students have the same number. Wherever you are from, probably have some sort of social security number, social identification number, whatever it is it's called where you're from. Every country has something different, but basically the government gives you a number and this is who you are. Same idea. So those are primary keys, they're unique. In a relational database, when you have two tables, each table has its own primary key, but they may inherit the values of the other table's primary key. That's how it does the connection. And way for you guys to picture this is when you have your phone and you have your contacts, right? And your contacts obviously have a phone number of some sort. So your phone number is your primary key and you're related to all your friends' phones because they got a copy of your phone number in their phone. Therefore, you have a one-to-many relationship with your people that have phones. It's the simplest example I can give you that's actionable in your hands that you can feel. When we talk about databases, this is something you'll learn about a fair amount in level 2, but when you work with a database, often you will be given a diagram. It's known as an entity relationship diagram. Uh, Someone will call them an enhanced entity relationship diagram. There's multiple flavors of them, multiple notations of them. Go figure, because in computers, you'll learn this soon enough. He always thinks they can do it better than the other person. Thus, they go and do their own thing over and over and over again. But essentially, an ER diagram or an ER model is a graphical representation of the structure of the database. You can look at it to see what makes up a table. Usually it has the relationships, the lines on it too, so you can see how the tables belong to each other or who's connected to what. Uh, Realistically, you don't need to know much about it this semester, but later on you'll learn about a lot more about them. There's a fair amount of theory that goes behind these diagrams, actually. All right, schemas. Schemas are an interesting topic, um, specifically because different database servers use the word differently. So, and schema is the same thing as a database. In some database products, the schema is a subset of a database. But essentially, all said and done, a schema is basically a box that holds everything together. So, anybody here ever work with an account? Dealt with an account? No, the one person's going, yeah, maybe. Okay, so really hard when I can't use the accountant as an example. Um, so picture a filing cabinet, right? And then the filing cabinet has drawers on it, right? You open the drawer, and inside of that, you've got different files. The filing cabinet is the database server. The drawer is a schema. Each of the file folders is a different table, and each piece of paper in that folder is a record. So if you want a visual representation when you're sitting there typing away of what it's like, just picture a filing cabinet. You know, you you're you're right in front of the filing cabinet. You need to talk to the world schema, the world database. So you open up the drawer that has to do with world. Then you want to look at the contents of the city table. So you'd look at the city folder and then grab all the sheets out of it. And that's literally what you're doing when you're querying a database. Just giving you the visual. Because after this week, there's not a lot of visual. So trying to give you the real world connection as much as I can. You can set permissions. There's rights, there's rules, there's all kinds of things you can do. I'm going to skip the word namespace because you guys haven't gotten there yet. A schema is a database is a schema for like 95% of the products. So good enough. A database that actually defines relationships between tables is known as a relational database. That is the majority of database products on the market, except for the non-relational databases such as MongoDB, Cassandra, what they call the NoSQL database servers. Those are an abomination. At least I find them to be an abomination because I've been a relational database person since 1996, so heading on 30 years. Um, Relational databases are all about structure and interconnections. So now, a database server will have something called a DBMS on top of it. What's kind of interesting is you have a database server, you can't actually read the files directly. They're in some proprietary format, they're in binary, you cannot read it. It's you open it up and it's just noise. That's because there's a database management system sitting on top of it. It basically is the interface between the operating system and the files. And it handles all the communications with whatever it is you are trying to do. If you got an application, so you got a web application where you're going to submit, a registration of some sort, there's a form. What it'll take the contents of that form and feed it into the database structure. It takes care of the translation of, whatever you're trying to do to an actual stored content. It's also able to retrieve it for you, and it lets you change it and update it. It controls access. It enforces the rules, makes sure of something called concurrency, where if you got two people trying to touch something at the same time. The DBM, whenever you hear somebody talk about a database server, they're referring to the DBMS. Essentially, it's a piece of software, it runs on your computer. It does not have an interface. It's just running in the background all the time, just waiting for someone to tell it to do something. Whether it's, please give me this information, or here, I just got some new information for you. Please put this in the database. That's what the DBMS does. And there's tons of them. Some of them you've probably heard of before, and some of you probably have not. MariaDB and MySQL, this is what we're using in this program, this course. Oracle, when everybody says database, usually Oracle is one of the first things they think of. Is it a good product? Questionable. But they've been around forever, and they've got a lock on large industry and government. So it doesn't hurt to learn Oracle if you get the chance. Microsoft SQL Server. IBM DB2. IBM DB2 plays in the same world as Oracle. Microsoft SQL Server tends to operate like one level below. Microsoft SQL Server operates in the same world as MySQL and another one called PostgreSQL. PostgreSQL is the most advanced database, open source database server. Again, that one's also worth looking at if you have spare cycles, which you won't have as a student, but just saying. And then you go down from there to like things people shouldn't use. Access is an example. Microsoft Access, terrible. People use it, but it's terrible. Um, Actually, at least at Health Canada, nobody's allowed to use it. It's product non grata. Nobody's allowed to use it. There's been too many problems over the years, so they put a blanket ban. They actually have to ask permission to get to use it. So, yeah. Um, so when we talk about the components of a database management system, there's the software, data, there's users, there's procedures, depending on what you're using. There's hardware. What is it running on? And you'll hear people say, well, my database is in the cloud. I've got an instance in Amazon. I've got an instance in Azure. I've got an instance in Google Cloud or Oracle Cloud. And I'm like, it's still running on someone's hardware. It's just not your hardware. You just, you know, offloaded the hardware problem to someone else. But there's always hardware somewhere. I've actually already described almost all of this. Hardware is literally the physical it runs on. Um, Procedures are things that can be shoved into the database. You actually learn about those in level 2. They're programmatic chunks that you can create to manage the contents of the database a little better. Data, well, it's data, it's information. Users, um, that's anybody who interfaces with the database, whether it's a developer that's going low level or somebody who's filling in a web form and hitting submit. They're all users of the database. Software and hardware, I pretty much explained that already. When we want to talk about, a database system, it includes not just the DBMS, but it includes the applications that talk to it. So, for example, you could have a database that's running in MariaDB or MySQL, and then a web application sitting on another server talking to it. For example, I like using, it's a web form, fill it out. You're going to go put a post on Reddit, a shit post on Reddit. You're going to go and go into a flame war on Twitter or X or whatever you want to call it now, that cesspool of hatred. Take your pick of products. Whenever you do anything, it talks to a database somewhere. So that's the applications. It talks to the DBMS. It does its magic sauce, and then it stores it onto the disk. And depending on what environment you're in, the disk setup can be simple, can be complex. There's a bunch of things that can affect it. Most database servers will run on a potato, except for Oracle. Oracle's pretty terrible. Microsoft SQL Server is barely better, but MariaDB, MySQL, Postgres will run on almost anything. And I'm not kidding, because I used to have a version of Postgres that ran on a phone, just because I could. I found it and I actually could write queries on my phone. It was such a pointless exercise, but I could. Raspberry Pis, those things are like, they're this big. They've gotten a lot better, but it'll run on almost anything. So it's good to know. So why would you want to use a database? It controls data redundancy. If you have certain rules set up when the data goes in, it lets you put in duplicated information. If your database is designed properly, you won't have duplicated data, constantly repeating the same thing over and over and over again. There's sometimes you just want to allow it to replicate data like city names. There's no point trying to abstract that because depending on where you're from, that's an awful lot of things to make unique. But things like countries, you don't want to repeat, political divisions like provinces or states, you don't want to repeat that kind of thing. It allows for data consistency because you can set up rules in the database server that says the data must have this. You're not allowed to add a piece of information to the database unless fields A and C are filled in. For example, here at the school, when they put you into the system, it requires you to have a first name and a last name. There's some countries in the world where people don't have last names. It's common. That's why you'll often see their records be their first name twice. I've seen several Priyankas in my years. Or you'll see Priyanka dot. They'll just put in a period because our system's so old that it doesn't understand the concept of not having a last name. It requires a phone number. It requires probably an email address. It requires a government identifier of some sort. So if you're Canadian, it expects you to have a SIN number. If you're an international student, it probably wants your student visa number or your passport number, or both. I really don't know what they collect on you guys. I've never asked. But if you're not allowed to add this person to the system unless you have this information, it's going to make the data more consistent. Data sharing. Once it's in the database, person A adds it to the database. If person B is allowed to read it, they'll be able to read it without having to make copies. You're looking at the same thing at the same time. Ease of development. Believe it or not, it makes certain kinds of development a lot easier, especially if your database is consistent. It'll improve your data quality because if there's no redundant data and your data is consistent, your data will be better. Data accessibility means that the data is available to more things to work with. If it's sitting in a centralized database, you can have multiple applications talking to it. For example, one of the teams I lead at Health Canada has two applications that talk to it. One that's internal facing and one that's facing the outside world. The one that faces the outside world is only accessible by the provinces and territories, but they're not part of Health Canada, but they talk to the same database. That means the person in the back can put data in, and somebody in Manitoba that has permissions to read it could read this data. It allows for data access by centralizing and providing multiple ways of spreading it. Okay, SQL. This is the course for the rest of the semester is SQL. You notice I'm saying SQL and not SQL. There's a lot of debate over SQL versus SQL. My argument, well, other than that's how, so that's why it sounds right, is two-part. Originally, IBM, which created the language of SQL, tried to call it SQL, S-E-Q-U-E-L, and they got their pants sued off by a company in England that already had a trademark. So they said, well, we can't use SQL. So we're just going to call it SQL, which makes sense because they're called IBM, not IBM. It's an initialism, not an acronym. You don't pronounce it, you say it. But you'll have a database prep go on this equal that, whatever. It just, it is standardized by the American National Standards Institute. Every so many years, they release an updated version standard. What the standard means is that if a database service says they're SQL 99 compliant, it means that they hold 99% of the features, or 90% of the features that were introduced in 99 as concepts. By the way, pretty much every database server is SQL 99 compliant. It's the newer flavors that are a little sketch. They add just, oh, we're not going to allow supporting JSON. We're not going to support XML. We want to make sure we have windowing functions, that kind of thing. That's what the standards mean. So if your server supports a certain standard, that means you probably have most of these features. It doesn't mean it's implemented the same way. It just means they offer you those features. So SQL language differs platform to platform. MySQL is pretty good. Postgres is very good. Microsoft SQL Server is not bad. Oracle is awful. Their version of SQL looks like the version I learned when I went through school. I learned SQL in '95. Just saying, their way of writing things in Oracle is bad. So be thankful you're taking MariaDB. You can use SQL to basically manipulate all your data. Add, create, delete, retrieve, create tables, drop tables, modify the tables. It's all command. An example of record from a database is select star from city, which is the equivalent to hello world for programming. Select star from whatever. Okay, MariaDB and MySQL. MySQL is a NARD DBMS. It's open source, free to use, kind of. Why do I say kind of? About 10, 12 years ago, Oracle was not happy that MySQL was starting to bite its heels, so it bought the MySQL Foundation. They just wrote a big fat check and said, MySQL belongs to me now. And then they let it stagnate. When the purchase happened, the founders of MySQL, they did what's called a fork. So it was open source. They grabbed a copy of the code and created a product called MariaDB. And there's actually 3 or 4 others, but MariaDB is the one that survived. For years, they are drop-in replacements for each other. You can take a database structure designed for MySQL and put it in MariaDB and it'll work. Vice versa. They're starting to diverge now a fair amount. Like they're not as compatible as they used to be, but they're still fairly drop-in replacement. Like basically the MariaDB people make sure that anything that's new for MySQL works in MariaDB, but not the other way, because that's Oracle that owns them. Also, MySQL is free to use unless you are an enterprise. If you want to use it on government computers, you actually have to pay a license to Oracle for it. You can use the community version, but then if anything goes wrong, you're just doomed. MariaDB, on the other hand, is completely open source. It's completely free to use, whatever. And I already told you about the split. And the last slide, man, I got like 2 minutes. JetBrains Data Grip is the tool you're going to use in this class to talk to your database. Works well. It's designed for SQL development. It's an administration tool. You can use it to export data. It does some diagramming, basic diagramming. It's a fantastic tool. And it's free to students and teachers. When you sign up for it, you actually get access to the entirety of this product. It includes PyCharm and like 18 different products you get for free with it. It's worth like $500 a year. So, it's good. Good time to be a student. Okay, so that's the end of this. So I will be putting up an announcement either tonight or tomorrow morning, depending how late it is by the time I get home. And then we will, your labs, what day's your lab? Because I actually don't remember when it's scheduled. Tuesdays? Okay, so you've already had lab 1 with Saif then. About Max, that he's not comfortable with Max. So just so you know. Yeah. I'm not comfortable with Macs, but I've dealt with them in long enough now that I'm usually pretty good at figuring out problems. So I've told Saif if a student has a problem and he can't figure out what it is, and it is a Mac problem, not just a database problem, send them to me. So if you're having problems trying to get whatever it is running because it just doesn't want to run, I can probably help you. Windows, you're good. No problems there. Okay. Outside of that, I've got to break and run because my next class is in 10 minutes. So I'll see you guys soon. Well, next week.